guys, how are you doing? You're going to need two things for this video. One is the PDF of your kinematic equations. Looks like this. And then the other one is the sheet that says learning to choose the correct kinematic equation to solve problems. We're not going to actually solve the problems just yet. I wanted to teach you a trick on how to pick the right equation. There's so many to choose from. There's 4 kinematic equations here that we can choose from. The purpose of the kinematic is there are going to be times where we don't have enough information in a problem to solve for physics, and they developed the kinematic equations, they're derivatives of each other, to be able to solve a problem when you don't have actually enough information. And so it's really handy, but sometimes choosing the right one is a little daunting. So I'm going to teach you a trick. So the first thing that I want you to do is take a look at your PDF, and you can see over here in the little box, the vertical box there, I have all of the knowns that you're going to need. And so this is the reminder. When you list your knowns, just like we've been doing all year, you want to list out all the little parking spaces. So we're going to start off with just copying. You can put that on your piece of paper here. Under your worksheet, under knowns, you can list them there, or you can put it on a piece of notebook paper. So V of F, V of I, delta X, delta T, and A. Those are all of our little parking spots. And so what we're going to do is read through the very first problem here, and we want to pick out all of those pieces. So it says a car traveling in a straight line has a speed of positive 30 meters per second at some point, some instant. After 3 seconds, its speed is a positive 20 meters per second. What is the average acceleration over this time interval? So it gives us some information. It tells us that it starts off at 30 and then it ends up going 20, and then that happens over like a 3-second period of time. And it's also asking us to figure out what the acceleration is. So we're going to write all those pieces down in our knowns. So we know that he starts at 30. We know that it ends up going 20. We know that happened over a 3-second period of time. And then here's the thing. It's telling us to find, or to solve for, the acceleration. So we're going to put a question mark next to that one. So our question mark goes next to the A for acceleration. Lowercase a. Uppercase A is area. There's one variable we don't know anything about. They don't ask about it. They don't tell us about it. And there's no question mark next to it here. And that would be the delta X. And so what I want you to do here is vote it off the island. It gets a big fat X. We have no delta X. So when you go to your kinematic sheet with the equations, we have our list of knowns. We have what number of the kinematic it is. We have the actual equation. And then over here, this is the key piece. This is how you're going to choose which one. In our case, we have no delta X. So we have no delta X. So when I look at my list, I can see right here, no delta X. I come back over and I can see that that's equation number 1. So it's going to be equation number 1. So kinematic equation number 1 is the one that we're going to choose. And so now I can set it up. So I'm going to write out my equation for kinematic number 1. V of F is equal A delta T plus V of I. And then you're going to substitute all of your information in preparation to solve it. Now I'm not asking you to solve these particular ones. I just want us to practice choosing the right equation. So our V of F is a positive 20. Our A is, I don't know, so I'm going to leave it as A. Our delta T is 3 seconds, and our V of I was 30. meters per second. And now we have a one variable equation that we can solve, and we can solve it for A, and that's going to tell us what the acceleration is. Cool? Let's try another one. So let's move on to number 2. It says a bear spies some honey in a hive and takes off from rest, accelerating at a rate of positive 2 meters per second squared. If the honey is a positive 16 meters away, how fast will his snout be going when he plunges into the hive? So let's list out our knowns. Go back to your PDF here. We have our list of knowns. Let's copy those down. V of F, V of I, delta X, delta T, and A. Now, let's pull our information out of our problem. Bear spies some honey. He takes off from rest. Takes off from rest. That means that he starts with a velocity of, you got it, 0. So his initial velocity is 0 meters per second. He's accelerating at a rate of positive 2. So this is positive 2 meters per second squared. If the honey is 16 meters away, that would be a displacement, positive 16 meters away. How fast will his snout be going? How fast will his snout be going? So, how fast will his snout be going when he plunges into the hive? That's a little tricky because we're talking about how fast. That could mean time. It could also mean velocity. But if we read the whole thing, we got to use our English clues here, or context clues there. How fast will he be going when he plunges into the hive? That's going to be a velocity. So we have to find out his final velocity. So which variable do we get to vote off the island? Our delta t. It doesn't say anything about the delta t in the problem. It's not asking us to solve for it. So we have no delta t. When we come to our problem sheet, which one is no delta t? What number? Is it number 1, number 2, number 3, or number 4? It's number 3. So we have kinematic number 3. So let's go ahead and fill that in. V of F whole thing squared is equal to V of I whole thing squared plus 2a delta x. Now, when you do solve these, when we get to that point, you have to remember your order of operations, right? So your PEMDAS, please excuse my dear Aunt Sally, or PEMDAS, you want to follow those when you solve. But really all I'm wanting you to do right now is substitute the numbers in so that you can set up the equation to solve. Our V of F is, I don't know, so we leave that as a V of F whole thing squared plus our V of I, which was 0, 0 meters per second squared. That'll be easy math because 0 squared is 0, plus 2, our A, is a positive 2 meters per second squared, and then our delta x. That's my alarm to get on my Google Meet to see you guys. Our delta x is positive 16 meters. There you go. All right.